Yo, what's good? So today we're gonna be doing a speed run of all the units in Chem 102. Not all today, but I got a final coming up in about actually a week now. I can't even drink water. Damn. What I was saying is that we're gonna be doing a brief overview of Chem 102, starting from starting from my starting from the very first unit, chemical kinetics. So I guess we might as well just get into it. We're just gonna do as much as we can, probably in about 30 minutes, and then I'm just gonna go to sleep because I got a psych final coming up tomorrow, and I did not study for that. Oh, bro. Okay, so what do we need to find? We need to find the order with respect to each reactant for this reaction. How do we do that? I really don't remember, bro. Okay, so I think we have to look at one where it's constant. So this is gonna be times 1, times 3, and this is times 9, right? So that means for A to the power of n was, say, n. Oh, you can't even see that. L M N. Oh, but we only look at products. I mean, we only look at reactants, so we could just call this N and M. Now this should be equal to the change. Bro, I'm low-key tweaking, bro. Okay, wait, let me just do this another way. How do I even write this, bro? Okay, so we're gonna write these two. Okay, bro, what am I even trying to say, bro? Okay, we're gonna write these in a way like we're gonna write them in their, like, I don't even know the word, but it's like this. Like the K expression, I think it's called. Like something like that. I think. I'm actually like not doing this right, I think. Because K is going to be the same for all of them, right? Because it's at the same temperature. So now, okay, so K. So because B is constant in this one, these two will cancel out. We'll be left with 5 over 9. Wait, no, what? 5 over 45, and then 1 over 3. Does that kind of make sense? Okay, so now from here we could just determine, like, n equals 3. Not negative, bro. Yeah, equals 2, bro. 1 over 3 squared is equal to 1 over 9. So therefore the order for n is 2. Damn, bro, I'm actually rusty, bro. Allow it, bro. Allow it. Okay, so for the next one, you can just do the same thing now. Here, we're constant. Here, times 2. Here, times 2. So just from that, I can tell that m is equal to 1. Because it's the same, to the same power, you know what I'm saying? Because, how do I say this? 2 to the power of 1 is 2 to the power of m, right? Is equal to 10 divided by 5, which is equal to 2. So n equals 1. First order, second order. So A is going to be second, B is going to be first. Nice. Okay, bro, that was rough. Okay, question B, write the rate law. That's easy. Rate equals the power of 1. Right? Yeah. Don't forget K. Wow, I forgot that, bro. But yeah, that should be the answer, bro. Is it raining? Bro, oh, okay. Now question C. Calculate K using the data from experiment 1. Okay, so we don't know what K is, but we can just isolate for K. So right now I just isolated for K. Now we're going to substitute them in from experiment 1, it says. So 5.00. Got 5,000. Oh, what's the units going to be though? This is going to be m squared. This is going to be m, so m cubed, m negative 2, min negative 1. So let's just keep the significant figures. And is that consistent with the overall order? Yeah, because the overall order would be, so that means if we could just, so it would be negative plus 1. So it'll always be min negative 1, but this will be negative 3 plus 1 equals negative 2. So it'll be multiplied to the negative 2. Yeah, there you go. That makes sense. There you go. That's our first answer. Let's move on to the next. This is a struggle, bro. But this next one's even harder, bro. Man, I wanted to try getting through this entire set by. Bro, I just lost the screenshot, bro. By today, but I don't think we're gonna be able to get all this done, bro. So I guess we'll just continue on with tomorrow. Tomorrow I have work though. Okay, how do we do this? What did I do, bro? Okay, so step 1 is look for something consistent. Okay, so here we're consistent. Times 2 times 2. So we'll call this L, M, and N. So from that, we already know that L is going to be equal to L equals 1. Yeah. Because this is times 2, this is times 2. 2 to the power of L equals 2, L equals 1. Okay, there you go. That's the first step. Now step 2 is find the other consistent ones. Well, here, we're consistent between this, not consistent, times 1. Okay, so that's a bit of a more challenging one, I guess. So we're going to put reaction 3 over reaction 2. That's going to be 2 to the power of m is going to be equal to 1. M equals 0, because 2 to the power of 0 is equal to 1. So m equals 0. That's done. Now find the third one. How do we do that? Well, if this is times 1, if this is consistent, this is times 2, then this is going to be times 1. Sussy, bro. What? Why is it not? I would assume that it would be. Oh, because that one's not consistent then, right? Yeah. Because the other ones work because like when we do this one for say, like when we're looking at this one, this and this are both consistent. And when we're looking at this one, we can't look at this one because this one's changing. So that doesn't work. So in that case, I think we have to fully substitute it in and then solve for it. Bro, what? How do you even do that? Well, I'm so confused right now. Well, we gotta look for them. Okay, so I guess we gotta change from here. Change from here. The other ones are not consistent though. But I think now that we have these two other values, we just have to simply write out the rate law and then solve for it. So I guess we're gonna do that. Okay, so I'll use 1 here. Now I just divide these two, I believe. Why am I even, bro, what? So this cancels out. Oh wait, forgot to put in the H plus. So 8 divided by 4 divided by 1 over 2 and n equals 1. Okay, that was low-key challenging. Determine the rate law. Oh my god, bro. Oh my god. What is the rate law, bro? Oh, the rate law is just when you write it. Rate equals K. Bro, CH3CO. Bro, I need to sleep, bro. CH3 power of 1 times BR2 to the power of 0 H plus to the power of 1. Is that right? Yes. Guess we could just cancel out BR2 and not write it, but I don't know. Now we have to determine K. Bro. Okay, K is equal to K. We're just going to not write this one down because there's no point because that just equals 1. So K is equal to rate divided by, bro, I'm just going to substitute this and I don't want to do this. 1. We're going to use the reaction 1, so CH3COH is going to be 1 to the power of 1. H plus will be 1 to the power of 1. And then the rate, what would the rate be in this case? 4.0 times 10 to the negative 3. Yeah. Okay, now make sure the units are right. M negative. This is what? Units on the top. M S negative 1. Okay, make sure, here we go. The one thing you gotta remember is make sure your units of time are the same, are consistent. So 4.00 times 10 to the negative 3 moles negative 1 S negative 1. Another way to check if our units are right is look at the overall order of the reaction. So now what should the units be? Yeah. So there you go. There's our answer. Next question. Gonna keep on going until like 8:15. How many questions are here? 8? 9? 9? Bombaclot, bro. What question are we on? We're on question 2. Oh, actually, no, we're on question 4. I skipped 2 of the early ones because, like, what the heck? Oh, now we're looking at, like, the rate equations and BS. Okay, I want to at least get 2 more done. This one I'm going to speed run, bro. This one cannot be hard. I just need to pull up my formula sheet. Formula sheet. My formula sheet. Okay, let's try figuring this out. The reaction A to product is first order in A. Okay, so what do we do with that information? Initially A equals 0.8, and after 54 minutes, A equals 0.1. At what time is A equal to 0.025 moles per liter? What is the reaction rate when A equals 0.025 moles per liter? Okay, well, first order. Here's the equation. This is based on my formula sheet. I don't remember these, but all I remember is that the first one is 0 order, second one is first order, and third one is the second order one, in order of what I'm provided with. Okay, so ln A of t is equal to negative kt plus ln A naught. So that's like original or start or 0. So at what time is A equal to 0.025 moles per liter? Well, that is a good question. How do we do that? At what time? We have to solve for K. Oh, and we have initial and time. So we just gotta... Oh my god, bro. Why are they making you do all this, bro? Okay. Here's another equation that I got. T is equal to ln. Remember to flip the sign. I believe that's right, if I'm not mistaken. Oh wait, we're not trying to find time right now. We're trying to find K. Whoa, am I dumb? K times 1 over T. So now let's just substitute this in and find K. So initial K is equal to 0.800. But I just realized, like, why am I even recording these, bro? Maybe I'm just lonely. But I don't know, maybe it'll be like, it helps in that I understand it, but I feel like it's not really helping in this kind of time, because I'm just speed running this. I'm not really talking right now, but it's okay. I'll remember myself like doing these questions while talking to nobody, and then like it'll be stuck in my memory, you know what I'm saying? So that's the method, bro. That's the method. Shrink. Okay, wait, remember the units. 0.0385 min negative 1. Oh wait, that's not even the question, bro. That's the K, bro. Why am I boxing the answer, bro? Why am I... Okay, now we simply just have to solve for time now. So we just do the same equation. I'm just going to put these values in 0.8. Bro, I remember I ate shit on this quiz, bro. I actually did so bad on it. It was the first one. Now we simply just put this into the calculator. That is right. What? Wow. 90 minutes. There you go. Part A answer done. B, what is the rate of reaction when A equals 0.02? Oh my god, bro. I'm actually going to tweak. Okay, rate equals K times A to the power of first order, so to the power of 1. K equals 0.0385 min -1 multiplied by a 0.25 moles. Multiplied? Yeah. 9.63 times 10 to the negative 1, 2, 1, 2, 3, 4. What's the units? Okay, there you go. Yo, my question is like, is this part just that easy, bro? The part B? That seems a bit sus. Like, I feel like we have to do more, bro. Do we not? I saw you dancing in the rain. That shit's really fucking gay. 7, a certain reaction. Bro, I really don't think we're gonna get through all these questions. Okay, yo, I'm gonna finish question 6 today. Then, 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 a certain reaction has the following general. Bro, I really don't know which question I'm trying to do right now. I guess it makes sense that we just go in order, so we might as well just do this. I know you're in pain. I saw you dancing in the rain. Really fucking gay. Bro, can this like move? Okay, bro, let's try this question now. Do we have enough space? I don't believe so. We'll just do it like that. Okay, let's try figuring this one out. Oh my god, bro, this is actually good. The following first order reaction occurs in carbon tetrafluorochloride at 45 degrees Celsius. The rate constant is K equals 6.2 times 10 to the negative 4 over a second. An 80 gram sample of N2O5 and CCl4 is allowed to decompose at 45 degrees Celsius. How long does it take for a quantity of N2O5 to be reduced to 2.5 grams? How do you do this, bro? Yo, this is gone, bro. Where's the flame machine? Okay. Okay. Okay, so what order? Okay, first order reaction. Okay, first order reaction. Bro, okay. This is the first order reaction. We need to find out how long it takes for something to be reduced. What I remember is that we could just use the same units because it's the same compound, so the units will just naturally cancel out. And then that will be used as the ratio for the ln, and then we just calculate time. So that's what we're going to do. I hope you kind of followed through with what I'm doing, because I'm going to speed run this. Ln over AT 1 over K. Okay, let me break down these units. Okay, wait. What is concentration? Concentration is moles per liter. Now, take this for example. Moles is equal to mass divided by grams per mole divided by molar mass, right? So now we got mass. If we put this into here, mass over molar mass over liters, right? And now we're taking the division, because this is the top part, right? This part is right here. Now we're going to take this part and put it down here. Let me just delete that part. Now we're going to divide all this by the same thing. Now keep in mind, liters is constant. Moles is constant as well. The molar mass is constant, so it's just the mass is the difference. So we just put mass over mass. You know what I'm saying? So this is equal to ln mass original over mass at time multiplied by 1 over k. Now that's equal to mass original, so that's going to be 80 divided by 2.5. Bro, I need to end this. Bro, I need to go to sleep. I need to go to sleep. Multiplied by 1 over 6.2 times 10 to the negative 4 as negative 1. Bro, it's too dark. I can't even see my calculator anymore. Divided by 2.5 divided by 6.2 e negative 4 equals 5.59 times 10 to the 3. What are the units, bro? Grams cancels out. Seconds. That's the time, right? Okay, we're cooking. Okay, now next one. How many liters of oxygen measured at 745 millimeters of mercury and 45 degrees Celsius are produced up to this point? How do we do this, bro? What? Okay, so we have the time. Could we use that? Or, okay, we have this reaction. I think I'm onto something. N2O5 N2O4 plus 1 over 2 O2. Okay, so we have like the moles, right? You know what I'm saying? Like we have 1 mole here. Wait, why am I using 1 mole here, 1 mole here, and then we have half a mole there. So we know how much N2O5 reacted, so therefore we could calculate how much oxygen reacted, and therefore finding out the moles of oxygen, we could calculate the volume through PV equals nRT. I remember that. I remember doing this. This was a long time ago. So AT minus 2.5 equals 77.5 grams. How many moles? Oh, we have to do that as well. What's the molar mass of N2O5, bro? I actually hate this, bro. Moles per liter. Grams, moles. What am I even saying, bro? I have a psych final tomorrow, bro. I should be sleeping by now, bro. But I'm not stretching, bro. Okay, 77.5 grams. Okay, molar mass of N2O5. 108.0 grams per mole, moles per gram. Divided by 108. Okay, this is the last question and I'm going to sleep timer. 0.718 moles N2O5. Now we just have to match the moles with freaking oxygen. So what is N2O5? N2O5 needs to go on the bottom. So we just divide by 2. 0.36 moles of O2. Okay, so now PV equals nRT. What are we looking for? Volume. Volume equals nRT divided by P. So moles 0.36 moles multiplied by the R constant. What's the R constant, bro? Oh my god, bro. Okay, so it's going to be 0.08206 liters times ATM divided by mole times Kelvin multiplied by, what's the temperature? 45 plus 273.15, just 318.15. Kelvin cancel, divided by pressure. Pressure. No pressure. 745 millimeters of hydrogen. I mean, millimeters of. Bro, we have to change that as well? Okay, bro. How do we even do this, bro? Okay, I think it's 745 divided by 760 ATM. Put that on to the calculator. I am not trying to do all that, bro. I'm just going to look at the answer, bro. What's the answer? Let me just make sure everything matches up. Okay. Yeah. 9.56 liters. Done. Bro, I'm going to sleep. Goodbye.